Hey guys, we're going to continue simplifying radicals, only this time there's going to be exponents. So we need to remember our exponent rules. That is, when I'm adding exponents or when I'm multiplying, it's the same as adding. When I'm dividing exponents, the same as subtraction. Now, the other thing I'm going to bring up is finding the square root of an exponent. And we'll get into this a little bit more detail, but just in a nutshell, if you have an exponent on a variable and it's an even number, divide by 2 and pull that out. If it's an odd number, subtract 1 and then divide by 2 and pull it out. Okay, that's, if you can remember that, that'll be a big help for this, but you'll see what I mean. I'm going to do a whole bunch of examples and I'm going to speed through really fast. So make sure you don't have to listen to everything I say, but make sure you write it all down so that you can refer back to these notes. Okay, for example, if you look at right here where it says remember, it says that x squared, that's an even number. So I'm going to divide it by 2. Well, it's the same as, let me just work it out. It's the same as x times x. There's a pair. Remember we talked about pairs yesterday, and so I can pull it out. Also, to the power of 2 is an even number. So if I divide by 2, that's 1, and I pull 1x out. All right. I wrote some notes off to the side. You might want to copy that down. It's kind of helpful. You'll see it worked out. So we know that this first example is just going to be x. X to the power of 3 is the same as x squared times x. So again, there's that perfect square x squared, so I can pull that out. The other x gets left behind. Again, that is an x to the power 3 is odd. So if I subtract 1 from it, I get 2, and that's what I divide by 2 and pull out. I know, crazy, right? You're going to see what I'm talking about. Just hold on. X to the power of 4 is x squared times x squared. So I can pull x squared out. Again, it's an even number, 4. Divide by 2, that's what I pull out. Next one, x to the power of 4 times x to the power of 1. All right, so I already know I take that x to the power of 4, divide it by 2, pull it out. The other x gets left behind. X to the power of 6. That is an even number. So I'm going to write this out. You don't really need to do this every time, but I'm just showing you. I have pairs, so I can pull one out. Again, x to the power of 6 is an even number. Divide by 2, pull it out. Here's another one. X to the power, in fact, I'm not going to do all of these. Let's skip some. All right, here's one we're going to do. I'm going to go ahead and do prime factorization. So I have 48, and I have 2 times 24, 2 times 12, 2 times 6, 2 times 3. All right, remember we're looking for pairs, and we're going to pull those out. I have 2 2's here, so I'm going to pull that out. I have 2 2's here, so I'm going to pull that out. And that the 3 is going to be left inside. I have a to the power 3. A to the power 3 is the same as a squared times a, that's an a. A1. Okay. Again, that same idea. It's an odd number, subtract 1, pull the other ones, and then whatever you have left over, cut it in half. So I can pull a squared out, and it becomes a. So this is still left in there. The 3 is still left in here. And this b right here, it's still stuck in there. There's nothing you can do with it. So what's on the outside is 2 times 2 times a, which is 4a. And what's stuck inside the box is the 3, the a, and the b, and we are done. Fun, fun. Let's look at this next one. The next one's different because it has a 4 on the outside. So whatever we pull out is multiplying with that 4, so keep that in mind. So if I look here, this is a 4 and a 3. So I can pull out, well, I'll go ahead and break it down more, 2, 2. So I can pull these 2's out. I have g to the power of 9, which is the same as g to the power of 8 times g to the power of 1. So I can pull out half of that g to the power of 8. Then I have h to the power of 4 times h to the power of 1. So let's do this. The 4 is already out there. I'm going to pull the 2 out. G to the power of 8, I'm going to half it and pull it out. H to the power of 4, again, it's even, so I can half it and pull it out. All right, what is left inside? I have a 3 left inside. I have a G left inside, and I have an H left inside. On the outside, 4 times 2 is 8. G to the power of 4, H squared. That's on the outside. Inside, I have a 3, a G, and an H. Oh my, that was totally fun to do. Let's keep going. That was sarcasm, by the way. Let's keep going. All right, now we have fractions. Now, something to remember with fractions, you never, ever want to leave a fraction on the denominator. Now, all these are going to work out really pretty. We'll learn more about what to do when you do have a radical on the denominator, but you want to keep that off. So look, I have 12 over 27. So I can see that I can divide both of these by 3. So I'm going to simplify it. Inside the radical, I've got a 4 and a 9. I can divide, just so you know, that radical can be divided up to where it's on the top and on the bottom. And fortunately, these are both perfect squares. Wasn't that convenient? There we go. Let's go to the next one. 5 and the 9. So I can again break this down. 5 and 9. The 9 is a perfect square, which is great because I don't want to have a radical on the denominator. And I'm done. Perfect. Next one. Both of these are perfect squares. I can go ahead, I'm going to break it down because we can't always get rid of both radicals, but we're giving you nice, pretty problems. 36 is a perfect square. X to the power of 4, I can half it, pull it out. X squared. I am done. All right, a to the power. Now look at this next one. This is where we pull in what we learned way back when. I don't even remember what unit. So let's just go ahead and see what we have here. We have a to the power of 5. And underneath it, I have an 81 and an a to the power of 1. All right. Remember when we have, this is division. Division is an exponent. It's a variable with an exponent. So I'm going to subtract. The 81 I can pull is a perfect square, so I can pull out the 9. So here's what we end up having. I'm going to pull out the 9, and then at the top, I have a to the power of 5 minus 1, which is a to the power of 4 over that 9. A to the power of 4 is an even number, so I'm going to half it. A squared over 3. Lovely. There we go. Okay, I'm going to do just one more, just really crazy one. Okay, so you can see crazy. So here we go. Next one. I'm going to break this all down. Number 5, I have a square root of 80 over a square root of 25. I have x to the power of 7 over x to the power of 3. I have y to the power of 5 over a y. So I'm going to remember all those rules. When I'm dividing with exponents on a variable, I'm going to subtract. So the 80, I can break that down into 5 times 16. The 25 is going to be 5. 7 minus 3 is x to the power of 4. 5 minus 1 for the y's is y to the power of 4. All right, let's pull out what we can pull out. I can pull out the 16. 4 times 4 is 16. So I'm going to pull a 4 out. The 5 stays in. Whoops, let me. I can pull the x squared out. I can pull the y squared out. And then again, there's where I'm going to go ahead and put the 5 in. And then I have a 5 down below. Oh my. That's about as hard as it gets for right now. Good luck. I'll see you later. Bye-bye.